so when we talk about a solution and you are dissolving a substance into a solvent, there is a limit to how much solute will dissolve in a given solvent. So a solution can either be unsaturated, where I can keep dissolving more of a substance in there. So let's say that I have a cup of tea and I'm putting a little bit of sugar in and it dissolves. Well, that means that that solution is still unsaturated. I can keep dissolving more. So if you see that it's dissolving, it's probably not saturated yet. A saturated solution, no more solute will dissolve. So if I have that cup of tea and I'm dumping sugar in there and it's not dissolving anymore, that means I have a saturated solution. I will not be able to dissolve any more sugar at that point, at that temperature. A supersaturated solution, I have gotten more of the solute to dissolve than I should have in that solution. So with a supersaturated solution, you're going to have more solute than that given limit. Usually what happens to make a supersaturated solution is you heat up the substance. So you heat up the solvent and then you put in the solute, you put in more solute, and then it will dissolve because it's hotter. Well, then at that point you cool it back down to temperature, to maybe to room temperature, and it is supersaturated. At that given temperature that it's at right now, it's supersaturated. So let me show you what it looks like when I have a supersaturated solution and I disrupt the equilibrium. So right here in this picture, I have a supersaturated solution with sodium acetate. So I have more sodium acetate than I should have at this given temperature. Now, the thing with supersaturated solution is if you disrupt it in some way, so I could add a little bit more of the solid to it, or I could just simply agitate it somehow, I can start to get the crystals to come back out of the solution. So basically it's the opposite process of it dissolving. So now what you see here are all the crystals forming again. So the substance that was dissolved in the solution, okay, is coming out and it's forming a solid again. So it's crystallizing. So that is what it means when the crystals come out of the solution. When we talk about solubility, okay, solubility is the maximum amount of grams of that solute that will dissolve in 100 grams of whatever the solvent is at a certain temperature. So if you change the temperature, you can change the maximum amount. So typically with solids, what you're going to see is that the solubility increases with the temperature. So this is a solubility curve. It shows you how much can dissolve at certain temperatures. And this is all based off 100 grams of water, or whatever the solvent is, but usually it's water. So if I'm looking at like sodium nitrate, well, if I go to 30 degrees, it says that I can dissolve about 95 grams in 100 grams of water. So at 30 degrees. Now, if I increase the temperature, I can increase the amount that I can get in that solvent. Okay, so typically when you look at the solubility curve, if the amount of solute dissolved is below wherever the line is, it's unsaturated. You can dissolve more in there. If it's on the line, it's saturated, and if it's above the line, it's supersaturated. So let's look at some problems with the solubility curve. So how much potassium nitrate will dissolve at 70 degrees? So go to the line for potassium nitrate, go to 70 degrees. So here we go. And it's about 140. So it's about 140 grams that we can dissolve. So the next question says label your solution as saturated, unsaturated, or supersaturated. So if I have 50 grams of potassium nitrate at 20 degrees, is it saturated, unsaturated, or super? So let's go to potassium nitrate. Here we go. Go to 20 degrees. Just make sure you're looking at the correct line. It's about 35 grams. So I can dissolve 35 grams in 100 grams of water at 20 degrees. Well, it's saying that I have 50 grams. So if I have 50 grams, that means that I have more than I should. So if I have more solute dissolved than this solubility curve says, it is a supersaturated solution. Okay, so let's look at sodium nitrate. So here we go, here's sodium nitrate. It says that we have 25 grams of sodium nitrate and 50 grams of water at 35 degrees. So remember, this whole thing is based off of 100 grams of water. So essentially I've cut the water in half. So let's go ahead and look at to see how many grams will dissolve at 35 and 100 grams of water. So let's go to 35, we're here. That's about 95 grams, okay? So for that given temperature, okay, so at 35 degrees, I can dissolve about 95 grams in 100 grams of water. Well, in order to compare what I've got here, I really need to cut the water in half. So if I know that I have 50% of the water, so it's 50 divided by 100, right? That's 50% of the water that I could have. I multiply that by the amount that I could dissolve at that temperature, it's going to give me 47.5. So if I had 50 grams of water, I could theoretically put 47.5 grams of that sodium nitrate in the solution at this given temperature. So let's compare what we have here. So it's saying that they only have 25 grams, but I just found out I can dissolve 47.5. So this would be an unsaturated solution. Okay. So the next one says at 55 degrees, how much potassium nitrate can be dissolved in 40 grams of water? So let's go to potassium nitrate. Here we go. Let's go to 55 degrees. It's about here, roughly. All right, so I can dissolve about 90 grams roughly. So I can get 90 grams at that temperature at 55. Okay, so I can get 90 grams in 55 degrees. So that's in 100 grams of water. Well, I don't have 100 grams, I only have 40. So 40 divided by 100 is about 40%. So if I multiply that, so 40% by 90, I'm going to get about 36 grams. Okay, so I can dissolve 36 grams of potassium nitrate at that given temperature if I have 40 grams of water. If I had 100 grams of water, I could do 90. All right, so solids are going to be more soluble at higher temperatures, typically. Gases, though, are going to be more soluble at low temperatures and then also high pressure. So if you think about soda, so soda has your solvent, but it also has carbonation in it. So there is carbon dioxide, the gas, inside your soda. So you're going to have a soda that is more effervescent. It's going to have more carbonation at lower temperatures. So if you let the soda sit out at room temperature or even a high temperature, you're going to lose a lot of that carbonation and it's going to go flat.